Assalamu alaikum, boys and girls. Our today's topic is moment of force. You people are familiar with this topic or this term already. It is also called the torque, moment of force or torque. Simply, we defined it as the turning effect of a force about a pivot. What does it is a pivot? Pivot is a point about which an object can rotate. If you consider a door, when we open the door, it rotates about its hinges. So hinges are the pivot of the door. So door has ability to rotate. Every time when we open the door, its movement is called rotation. So because it is moving about a fixed point. So if an object moves about a fixed point, then its movement is called rotation. So turning effect, we are producing turning effect in the door when we apply a force on it. So simple definition of moment is turning effect of a force about a pivot. Like in this case, if I apply a force at this point downward on a rod which can rotate about this pivot, we know it will rotate in this direction. If it is a door, it will rotate in a clockwise direction. It is your common experience that if you apply more force, the rotation would be greater. The turning effect would be greater. If you apply greater force, the turning effect would be greater. So it means the moment or turning effect depends on the force applied. So greater force produce more turning. Secondly, it is your experience that on door, always the handle is attached at the far end. We never seen a door with the handle over here or near the hinges. Why it is so? If we apply the force somewhere in the middle of the door or near the hinges, we need to apply a lot of force, lot of more force to produce small turning. So two factors on which the moment depends. One is the force applied, and second is the perpendicular distance between the force applied and the pivot. This is the pivot, force applied is here. This distance is the perpendicular distance between line of force, this is the line of force, this is pivot. So the distance between the line of force and the pivot, and it should be a perpendicular distance. Perpendicular means the angle between the force and this line should be 90 degrees. So perpendicular distance between the line of force and the pivot is important as well. The moment also depends on the perpendicular distance between line of force and the pivot. So we define the moment as the force which we are applying, because the moment depends on that force as well. Secondly, the perpendicular distance between the pivot and line of action of force. So moment is given by the product of force that we are applying F and the perpendicular distance between the pivot and line of force, this distance. So moment, we can say, is given by F into D. So F is a force which we are applying on this rod, and D is the perpendicular distance between pivot and line of force. Remember, this part is bit difficult to understand for the students. So always the students are confused between, if I consider this distance, it is the distance between line of force. Force is applied, say, at this point A, and P is the pivot. Force is applied here, but if I consider line of force, and take a perpendicular distance, means at a 90 degree, I take a distance between the pivot and this line. This distance is d. And this distance, as it increases, the moment increases, because moment is the product of force applied and the distance between the pivot and line of action of force. So moment applied to moment depends on two factors. One, the force, other, the displacement. If force is more, it produces more turning. If displacement is more, we need less force to produce turning. So greater distance helps us to turn the objects or turn or rotate easily. Is a simple example is of a spanner. If we have a spanner to open a bolt, if we apply the force, if we use a longer handle to open a nut or a bolt, it means we are using greater distance from between the pivot. This nut is a pivot. We are getting distance, greater distance. Then in this case, if we are using the longer handle, then it is easier to rotate the nut or bolt clockwise or inward, or to tie it or to untie it. If we use the longer handle, we need lesser force. It means it becomes easier to tie it or to untie the bolt if you use the longer handle. So remember, D is the perpendicular distance between pivot and line of action of force. If I apply a force here, the line of force, see, if I draw the line of force, it passes through the pivot. In this case, there is no distance between line of force and the pivot. In the first case, line of force and the pivot, the distance is d. In this case, the line of force is passing through the pivot. If I apply a force here, it doesn't produce any turning. It doesn't produce any turning. So in this case, the moment, in this case, the d is 0. Therefore, moment is 0. No turning is produced. The reason is the line of force is passing through the pivot. So the perpendicular distance between the line of force and the pivot is 0. So if I take the product of force applied and the distance, it comes out to be 0. Doesn't matter how much force you're applying, all this force get wasted because of 0 distance between the line of force and the pivot. If I apply a force in this manner over here, maybe you have to draw the line of the force. Pivot is here. Now, perpendicular distance between line of force and the pivot. This is the perpendicular distance. Remember, I told you, you have to take 90-degree angle between the line of force and the pivot. Line of force in this case is downward, pivot is towards the left, the angle between them is 90 degree. So I'm taking the distance, perpendicular distance between the pivot and the line of force. In this case, the line of force is diagonal. So if I take the perpendicular distance from the pivot, so this is D. Remember, the students makes a major mistake. They mostly take that, always they take this distance. This is, in this case, the D is, if we take this distance, it is wrong. In this case, you have to take the distance, perpendicular distance from the pivot to the line of the force. So you have to draw a dotted line of the force, and you have to take the shortest distance between pivot and that line. So now this D and F gives you the moment. So moment is the product of force applied and the perpendicular distance between pivot and line of action of force. Moment is a vector quantity because it has direction. If I apply force over here, it will produce clockwise rotation. So it is a clockwise movement. Otherwise, if I apply force in upward direction, it will produce anti-clockwise movement. That's why we can say that the moment is a vector quantity. We can produce two types of moments, clockwise or anti-clockwise, depending on the force. So what I means, if I consider a rod, if I apply a force over here, then it turns in this manner, or on the same rod, if I apply a force in this direction, it turns in this manner. So it is anti-clockwise moment. It is clockwise. So because it has direction, so we can say that moment is a vector quantity. SI unit for the moment is, we can see from the formula, force is measured in newtons and distance is measured in meters. So its SI unit is Newton meter. So let's have an example how we apply the moment, how we calculate the moment. The force applied to rotate this rod about pivot P is 10 Newton, and the distance between rod, perpendicular distance between rod and force applied is 0.5 Newton. So moment is F into D, that is 10 into 0.5 gives you 5 Newton meter clockwise. So it will obviously rotate in this direction. We say it is rotating in clockwise direction. So the simple way to calculate. Or if I consider another example, in second case, I am applying a force of 10 Newton on a rod, but I have mentioned two distances. One is between at the point where the force is acting and the pivot. Between the point of action and the pivot, that is 0.5 meter, and another is between line of action and the pivot, that is 0.3 meter. So in this case, to calculate the moment, I have to use for same formula, but D. I have to take the distance between line of force and the pivot instead of the distance between point of action of force and the pivot. I don't have to take this. distance, I have to take the perpendicular distance between line of force and the pivot. That would be 10 into 0.3, 3 Newton meters. Another term we have to discuss here is equilibrium. You people are already familiar with this term. When an object is in equilibrium, if sum of all the forces acting on an object are zero, then we say it is in equilibrium. If I say a book is lying on a table, its weight is acting downward, the action of the table is upward, both forces equal and opposite, they cancel effect of each other, so the book is in equilibrium. If sum of all the forces acting on an object is zero, then it is in equilibrium. Or we can say the resultant force on an object is zero, then it is in equilibrium. So when the object is equilibrium, when sum of all forces acting on an object is zero. Or you can say resultant force is zero. An object is in equilibrium. The second condition for the object to be in equilibrium is if a rod is balanced with two weights suspended, one to the right W1 and one to the left W2, if it is balanced on a wedge at point P, this is the pivot of this rod. If it is balanced, then we can say that the turning produced by W1 is equal to turning produced by W2, or moment of W1 is equal to moment of W2. We can say that clockwise moment is equal to anti-clockwise moment. If number of forces are acting on an object which can rotate about a fixed pivot, then if clockwise moments is equal to anti-clockwise moments, then we can say that the object is in equilibrium. So second condition is so we have two conditions for body to be equilibrium. One is sum of all forces acting on an object is zero. We have considered example of a book. Two forces are acting, weight is downward, reaction of the table is upward, both are equal and opposite, cancel each other, the resultant force is zero, we say book is in equilibrium. Second case is if an object has ability to rotate about a fixed point pivot, and we say that it is balanced by two forces W1 and W2. W1 is producing clockwise moment, W2 is producing anti-clockwise moment. If their moments are equal, then we say rod is in equilibrium. So these are the two conditions of equilibrium which have to consider, which we have to discuss in the later topics. Now the equilibriums are of three types. It is not in your syllabus, you don't have to worry about it, but we have to discuss a little about it. Stable equilibrium, You won't find it in your book, but it is, we have to discuss a little about it. In case of stable equilibrium, if I consider the example of a book, its center of gravity, this point is center of gravity of the book. If we lift it slightly, its center of gravity rises with it. Weight is acting downward and it is passing through the base of the book. But in the new position, again, if you consider the weight of the book, it is still passing through the base. At this position, I have applied a displacing force. If I release this force, this book will fall back to its original position because this weight is producing a turning, clockwise turning. Weight is producing clockwise turning. So in this case, the book returned to its original position. We say it is in stable equilibrium. Why it is so? Because when a displacing force is applied, the center of gravity is raised from its position. Secondly, the line of the weight is always passing through the base of the book. So in such case, if center of gravity rises on applying the displacement force, and secondly, the center of gravity rises from its position, then object is in stable equilibrium. Secondly, unstable. In unstable equilibrium, if I consider a rod, its center of gravity, weight is acting downward, passing through the base of the rod. In this case, if I displace it a little from its position by applying a force, its center of gravity goes to new position. As you can see, in the first case, the center of gravity was risen from its position, it goes up. Now in this case, it is lowered from its position. And if I draw again the line of action of weight, in the first case, the line of action of weight always acting at the center of gravity. So in this case, weight was passing through the base in both cases. Now weight lies outside the base, which rotates it in clockwise direction. So at this position, if I release it, it will fall. So we can say this object is in unstable equilibrium. Third case is of neutral equilibrium. In case of neutral equilibrium, if I consider a ball, its center of gravity now if I roll the ball forward, we can see that in both cases, weight is passing through the base of the ball, weight is passing through the base, its position is not changed, center of gravity's position is not changed at all, and weight is always acting through the base. So in such case, even if I apply a displacing force, deforming force, it doesn't, center of gravity, height of the center of gravity doesn't change, and the weight is always passing through the base. So in such case, we can say it is in neutral equilibrium. So in case of stable, center of gravity is raised. In case of unstable, center of gravity is lowered. In case of neutral, center of gravity remains at the same level. In stable, weight was always passing through the base. Even in this case, weight is always passing through the base. In unstable, the weight lies outside the base if we change its position, so that which topples it down. So equilibrium, what is equilibrium? If an object, if all the forces acting on object is zero, then we say it is in equilibrium. Or if sum of clockwise moment is equal to sum of anti-clockwise moment, then we say the object is in equilibrium. Principle of moments is an important topic which we have to apply in solving the problems. According to this principle, if an object is in equilibrium, then sum of clockwise moment is equal to sum of anti-clockwise moment. What we have already discussed here, but the principle says if the object is in equilibrium, object is already in equilibrium, then sum of about a pivot is equal to sum of anti-clockwise moments about same pivot. If object is balanced, is already balanced, then we can apply this principle. So according to this principle, if I have a rod balanced on a wedge having W1 on one side and two different weights suspended on the other side, if it is balanced about P, perpendicular distances are D1, this distance is D2, this distance is D3. If rod is balanced about the pivot, then clockwise moment is equal to sum of anti-clockwise moment. According to principle of moments, if rod is balanced or in equilibrium about P, then clockwise moment is equal to sum of anti-clockwise. So if I look at the diagram, clockwise moment will be W1 into D1. That would be equal to W2 into D2. Clockwise moment produced by W2 in this direction plus W3 moment produced by W3 into D3. So this is the statement for the principle of moments. So it says if an object is in equilibrium, means it is already balanced, and then sum of clockwise moments will be equal to sum of anti-clockwise moments. And we have considered an object balanced, a rod balanced with three weights suspended, one on the right, two on the left. The formula comes out to be W1 into D1 is equal to W2 into D2 plus W3 into D3. This formula will be used in the problem solving. So that's it from today. You must learn these principles. You have to learn this principle because it is all number of times it has been asked in the papers, and also the definitions. Thank you very much.